damage, they trip. And that has been the cause of our problem. What happens is that we have a grid that is working seamlessly at some point. Then something happened. What is that something? A main line that is evacuating 300 megawatts from Lukayani suddenly falls down. What happens? You are removing 300 megawatts of generation at one point when the consumption is at that level. Maybe we are at 2,000 megawatts in the country. Then pop, you remove 300 megawatts because of a line that has gone off from the generators. What does it happen? It creates something called under voltages on the lines. And the under voltage relays, as he says, does their work and trips. The first line to trip causes another cascaded effect. And within no time, all the generators are off, either on under frequency or on frequency. All the lines are off on over voltages. So that is what happens in Kenya. But what I want to say is that we've come a long way. After the last three outages, that Kenyans were not happy, and I respect Kenyans for that because they demand and they pay for the service. The ministry came up with a CREAT conference that brings all the players in the industry together, and they have been having serious conference at Suswa, and they came up with a myriad of suggestions and strategies. One of them that I'm happy to say is what our convener today has said. We are looking at a situation where we have islanding. Islanding is now, there is a problem on that line from Suswa. What do? We have enough generation in Mount Kenya, let Mount Kenya enjoy the power that is generated, the other parts of Kenya remains off as we saw the line. That has happened twice and I'm very happy. It never happened before. The last time the western side was able to remain when the whole of Kenya was off. That is a progress. The other time Mount Kenya remained when all of Kenya was off. That is progress. And I want to say it's progress because it avoids something called black start. Black start is when you are starting generators when there is no excitation for it to start. It is a very expensive, it creates delays, and sometimes you might not get it right on the first time. You generate before you peak, the load peaks a lot, and the frequencies come in. So we are looking at those issues, and what my colleague has said about the interconnection and having a closed grid. I would like to say that today, actually, I'm happy to be here today sitting with you. We are loading the first ring, Nairobi ring, that is Kimuka station that we energized on Sunday as KETRACO. We are loading today 2 feeders that will affect electricity, that will improve electricity in parts of Nairobi, and that is part of Nairobi ring. We are creating rings, and I can tell you with the projects that KETRACO has, that has almost 15 this financial year to commission, there will be significant improvement, and that is what we have been doing, and those are the interventions that we are looking at, the changing weather, the changing expectation of the people, and also the expanding network in Kenya. Thank you.
Yes, so let's have Engineer Kimeu add to it the beauty of meaning grids, distributed generation and off-grid systems, and I am sure those systems are also being made in such a way that they will finally amalgamate onto the grid when it gets to those places in terms of design and how that will help our resilience. Then we will have Engineer Kerr. I hope we will still have him once Engineer Kimeu has done. Engineer Kimeu from Makari.
Thank you very much. I will comment on 2 aspects. One, of course, is distributed energy sources, which is, of course, now becoming a common situation or common scenario. We know that our grid only covers certain parts of the country. There are major parts of this country which relies on off-grid systems. Of course, the beauty of those systems, the impact is not one when a plant is out. It will only affect a small part of that section. But then, because we also need to build systems which are reliable, which for reliable power supply for development of those, because those plants will supply also very critical infrastructure, an hospital. We then what does it mean to power away for a minute, for a day? An operation was going on in that hospital. And I think going forward, then we expect the population of those infrastructure to grow. The projection of the capacity of the militaries in this country is in excess of 500. So then when we have 500 hospital stations in this country, then how do we operate? So my suggestion is that we need to build infrastructure which anticipates the future phenomena, climate phenomena in the future, so that then we can build that reliability. The other thing, of course, is as we move forward, then we'll expect the capacity of the infrastructure to grow. Currently, we have a peak generation of about 3,000 megawatts in the country. What happens when we get 5,000, 10,000 megawatts? We have a more robust, a bigger infrastructure, which then we have to deal with. And one of the things that can help us deal with this issue is technology. We need to use technology more, build systems which can now talk to us as much as we talk to them, give us data back, using that data, a big data scenario, then we can analyze that. One of the other aspects, of course, I need to comment is, of course, is the oil and gas sector again, which is even more riskier scenario, because then sometimes then when the electric sector is interrupted, then what will happen is a blackout. Of course, we will suffer a few consequences of that. But with the petroleum sector, then when a phenomenon like this happens, there are likely to be a very massive loss of lives and damage to infrastructure. We had a small blast in the industrial area the other day, and we lost lives. Currently, of course, we are seeing a situation whereby now there is more transition to clean cooking. There is more use of LPG. The demand of LPG now probably was about 350,000 metric tons per year. We are seeing a situation whereby we probably will get to 500,000 metric tons, or even a million. And how do we build our infrastructure in a way that then what will be the impact of then an LPG bullet, of course, probably of 10 tons or 100 tons is swept away by floods, yeah? Or probably when you have a pipeline for such a case, which is swept away by floods. So I think that, of course, need to pick our minds as we plan, even in terms of location, so that then we climate-proof some of this infrastructure in a way that then we are not going to be losing lives because of such phenomena. So I think because of time, engineer, allow me to stop there to allow other members to comment.
Thank you, Engineer. Engineer Karen is able to hear us, so we can get his comments on the design, system design.
Thank you once again, and thank you for the very insightful discussion. For probably just probably conclude. Apart from what my fellow panelists have shared, we have this issue about climate change, as we know very well, provides for us as an economy, as practitioners, as engineers, as lecturers, gives us an opportunity to to create another path in terms of sustainable development. Right from the government's agenda, the bottom-up economic transformation agenda, we talk about the development blueprint of our country, Vision 2030, talk about Africa Agenda 2063, as well as the Sustainable Development Goals. There's an element of sustainability. All this require, reliant and safe infrastructure. The more the energy is not served, either as a result of disruption, there is more financial loss to the economy. We need to have energy that is reliable, energy that is adequate, energy that is there. for that, we need to have the reliable and sustainable infrastructure. So we have, and probably, I'm so glad I should have said this earlier. As of course, I've got the board from EBK, and also proud alumni of Moi University School of Engineering. I'm also a public student, public policy student at the Strathmore Business School. So I'm so glad that you're able to host. So I come in as both an engineer, I come in also as a carbon policy maker. And this issue about coming up with concrete policies. In policy formulation, we have what we call a policy window, where it gives, wherever there's a problem, if a government is addressing a problem, it will come up with policies. That policy is a document or a strategy of how to solve a problem. So we have different policies for different sectors or different problems. Now we have a policy window, and window of opportunity that as stakeholders we need to work together with it needs a comprehensive kind of all-round approach in dealing with this problem. So we need to develop the right policies. We need to have properly synthesized, having data very. I don't know where it's coming from. So we need to have the right policies, data-driven, decisions. For instance, if we're going to talk about there's a much dam, I think it's in Kileke County, a 30 billion project. Much dam is being constructed now, and from the they've been using 100-year rainfall and hydrological data. But in my view, the coming in of the issue of climate change, you may find that 100-year-old hydrological report may not be adequate. Why? Because there's a lot of uncertainty. Who knows after the God forbid, after the project has been launched, 30 billion project, I think it's supposed to provide, is it 8 million liters of water to confirm. But essentially, there's an issue of uncertainty because what happens now? Suppose the rain is not adequate, to sustain this dam. So there's a lot of uncertainty. That's why we need to have the right policies in terms of getting the right data, a lot of linkages in terms of research. If you look at a country like China, they have just talk about artificial intelligence. They have, I think by the year 2030, they put a budget of 66 trillion, shillings, equivalent of 66 trillion. And that is just for research. So even as a country, we need to think of how we can take this issue of climate resilience, climate change on a higher note in terms of adequate funding to the universities, adequate research. How can we have a nexus between artificial intelligence and how can we leverage on using artificial intelligence to solve some of the problems, coming up with the resilient infrastructure, because AI is there with us, and we have to find a way we can use this technology to address. And probably before even we can call it emerging technologies as well as indigenous technology. I'm just thinking how, for instance, the Manyata house, how resilient it is. When it is hot, inside it is cool. And when it is raining, again, we don't see what, of course, when you talk about the floods, then you may not be able to resist the flood. But we're talking about using emerging technologies as well as indigenous technologies to deal with the sustainability. Because yes, we can run in and talk about a lot about AI, but can we also use indigenous technologies and adaptive approaches to deal with infrastructure? So that's why research will be very, very important in terms of this issue. So in a nutshell, we need to have a well-coordinated policy approach as well as research. Another thing would be, we've talked about COP28, we've talked about even the one we hosted recently. So we need now more commitment from the governments and in terms of climate financing, because all these require a lot of finance. So I think there's a policy called LOCA, the one called LOCA. It's locally financed. What is it? But it's for locally financed solutions and financing. So we need to navigate how we can really finance these projects. Even in terms of academia, probably we need this, even a change of syllabus to include climate resilience right from school, engineering school, from first year, because climate change will be here in the long haul. So we need to have engineers, we need to have practitioners who they put design, the design aspect. When they're designing projects, it's not just business as usual. You'll have to design a project that or an infrastructure that is resilient, that is sustainable. So that should be put in place. And even here at the board, we'll do more in terms of capacity building. Just as I wind up there, we are currently in Nakuru, we're developing what we call career progression guidelines and schemes of service for engineers, technologists, technicians, artisans, and so on and so forth. And we make sure there is inclusion of issues about climate change, even in that career progression. So you can see how relevant it is in terms of both the career progression for the engineers as well as other stakeholders, and even in the syllabus in terms of capacity building to have these right competencies in dealing with this opportunity. I would say it's an opportunity because when we have this problem, then when we harness it, it becomes an opportunity. So in terms of also planning, we were talking about energy planning, a lot of, and even in terms of segmentation, the transmission networks, we may need to really rely more on this meteorological and hydrological data in terms of the design. And then also, as we talked about the existing systems, what happened to the existing system? Probably they may need to be retrofitted so that they're able to sustain or to withstand some of the changes that may come. A good example would be, when we talk about global boiling, where the high temperatures are, from what I remember in engineering classes in power systems, with the increase in temperatures, then there could be a possibility of increase in resistance, and probably that can lead to energy losses. So then how do we factor in the existing infrastructure? We need probably retrofitting, and that may need extra budget, and so on and so forth. So all this require a lot of comprehensive approach in dealing with this, coming up with the resilient energy infrastructure. And another thing also, just not just focusing on energy alone, because energy supports all these other sectors. As an economy, we are still way, way far, because if you talk about only approximately 2 gigawatts of power, and South Africa, I think they are 80 gigawatts. So we still have got a long way to go. I mean, only 2. So we need, as a manufacturing hub, upcoming manufacturing hub, we need to be talking about how we can have a reliable power. When we are talking about SGR, are we looking for a day when we have an, the one that is electric power? We are talking about the electric cars and so on. So there are so many standards to be developed. So this presents a very, very good opportunity for all of us to take our country to the next level. As I wind up, it's just to appreciate and to thank you organizers for giving us the honor to be participants in this very, very important workshop. I think probably we may need to have another one as a follow-up. Probably, because I don't know whether it was the sound from my end, but I had a bit of a challenge here in my fellow panelists. Probably we may need to have a follow-up on this with the resolutions that can go a long way, both to the board and to the policymakers. Some of these resolutions should go all the way to the National Assembly in terms of policy. Those are very huge implication in terms of policy. And finally, is to invite all of us. We are going to have as a board, Engineers Board of Kenya has organized for Engineering Partnerships Convention. We usually have, this will be I think the 5th, which is going to take place in May. That is 7th to 11th of May in Nyeri County. And I think we need to continue with this conversation because we will be still talking about issues about sustainability and resilience, infrastructure. So we'll be glad to continue this particular discussion in that particular forum. Otherwise, in a nutshell, we look forward as a country to be better prepared in terms of dealing with this climate change, having sustainable and resilient infrastructure for posterity. Because when we're developing this infrastructure, we are doing it for the generations to come and for preservation of the planet. Because let's be honest, engineering is the biggest contributor in terms of this climate change. Because if we are not having factories, we are not having roads, we are not having houses, we are not having all. I don't think we'd have the issues of, because we also need to have sustainable development. So, since the engineers and majority are the ones who are through their development and these projects contribute to this issue of global warming, so they should be on the forefront in terms of providing solutions and innovative solutions, for sustainable development. So thank you so much, panelists. Thank you also, the listeners, distinguished ladies and gentlemen, and we look forward to this continuous collaboration. And as they always say, is that in the midst of problems, there's always an opportunity. So this gives us an opportunity to provide innovative solutions, for prosperity, not only for prosperity, but also for posterity. Thank you, ladies and gentlemen.
Thank you, Engineer Okere, for those very enlightening comments and closing remarks. And I think we